Okay, so here we are again with the same system, but now we have a problem. We have a crank no start. So if I can get my helper in the cab to go ahead and crank it. Okay, so you can see and hear here that nothing happened. So we didn't get a click, we didn't get anything, we just got the key turning like that. So we have a no crank situation. So we know it's going to be specific to this starter circuit. So right off the bat, the no crank narrowed down the diagnostics to the starter system. Could be the starter that's failed, it could be a broken wire pretty much anywhere, could be this relay, could be the ECM, could be lots of things. So we need to start asking ourselves, what are some tests we can do that tell us the most amount of information for the least amount of work, okay? Now, a really good place to go is the fuse panel, okay? And we could start and check this fuse here, and we could do that. Even easier is to kind of start here at this relay, all right? So the relay, if we review that again, it is a coil here that when current flows through it builds up magnetism and it sucks this switch closed, okay? So it goes click and it sucks closed. So hearing that click or feeling that click with your finger can tell you a number of things. If I feel it go click, that tells me that this is working. That tells me that this circuit's good. It tells me that at least that this side of the relay is working. This maybe is clicking but not making contact, so it could still be a relay. But it tells me that this ground is good and this whole side of the circuit is good. Okay? If it doesn't work, doesn't click, then it tells me the problem's likely in here. So I can do one very simple, quick, easy test without a whole lot of work. Okay? So I'm just going to put my finger on the relay. Okay? And I'm just going to have my buddy crank it here. So if you can go ahead and crank the vehicle. Okay, and we have no clicking. So the relay didn't click. So that tells you the problem is likely here. Okay, so we're going to take and do some testing. Now, there's not really any point of checking this fuse. I can still check it, but I know the problem's on this side of the circuit, so I'm going to assume that likely this side of the circuit works. Now, why is it separated like this? Why even have a relay? Why not just have me turn the key and close this switch mechanically? Well, the reason for that is so that we don't get so that we can have a small amount of current controlling a large amount of current. So when I take and turn the key, and my key switch would send a signal to the ECM, and ECM can take and control it. The key switch, the ECM controlling, all these things can be tiny little wires because there's not much current flowing through them. So all these wires that come up in through our steering column can be really small. That saves money and makes it easier, right? If we had to have a big key switch that controlled this 40 amps that's going through this solenoid, that would have to be a pretty bulky key system and big wires coming up through the column. So that's why they do this. And then this side of the circuit can be bigger wires that's underneath here that we don't see. So that's why it's complex. Anyway, so to back up, we don't have a click. If we don't have a click, we know that we do not have current flowing through this side of the circuit. So I'm going to focus my energy on that. So I'm going to take and look at this relay. So I'm going to look at my fuse panel. You look at the fuse panel, it has a little map on it, and that map shows you where the starter relay is, where the fuse is in location. So I'm going to pull out the starter relay, and it shows me exactly where it is. And so I get 4 pins, and I can see, oh, that'll be these 4 pins here. And you see on the wiring diagram, we've got a 30, an 86, an 85, and an 87. Those numbers are actually on the back side of this relay, and it shows me where they are. They're actually also on this little map here and shows me where they are on here. Now that's very important with the relay because the wiring diagram is written as if these 2 pins are 86 and 85 and these 2 pins are 30 and 87. But that's not the case. It's not ever the case. They write the wiring diagram like this because it's easier to draw to have these 2 here and those 2 there. But in actuality, if it was wired this way inside this relay, I could flip this thing around and totally change it. I'd have a switch on this side and a coil on this side, and we don't want that. So all relays are wired diagonally, okay? So 86 and 87 are, 85 85 and 86, 85 and 86, the coil two are diagonal. So no matter that's 80, that's these two here, no matter whether I put it in like this or like this, it still stays these two, right? So then those two pins are always going to be the coil. It doesn't matter which way current goes through the coil, and it doesn't matter which way current goes through the switch, as long as we don't move the switch and the coil to different locations. Okay? So we have 85 and 86 on a diagonal like this, 30 and 87 on a diagonal like that. So I just have to match numbers and know exactly where I'm looking. All right, so let's take and let's see here. Let's test the ground first. Let's just make sure we don't have a bad ground, right? So I can go to pin 85. So I'm going to take a back probe because the test light's too thick to put in there. So I look and I find pin 85 and I find out where it is, and I go in like so. Now I'm testing the ground side. So to test the ground side, I need to take and hook my test light up to battery positive, right? So I have to make a known good power side of the circuit, which we've talked about. I'm going to verify that my test light works, okay, which it does, all right? And I'm just going to take and test the ground side. I don't have to turn the switch on or anything or turn the key because it's supposed to be a path directly to ground. So now I'm going to take my test light and touch here, okay, and go into here, and let me just double check. So that should be 85. Make sure. Okay, so 86 and 85, and it looks like we don't have a path to ground. Okay, so if I go here, I'm not getting a path to ground, and so it looks like we have perhaps a broken wire between here and ground. Okay, let's just verify the test light works and know what's not working there. Okay, and if I go up to this side here, okay, and I go in here, that's the battery positive side. Go into there. Okay. And okay. Helper, can you come back in here and go on the passenger side door there and do the key again for me, please?
Do what? Turn the key?
And the key. Okay, and we also don't have any power here, so let go. Okay, so we're still not getting power here as well either. So we have no power coming from here and no ground coming from here, all right? So I'm going to take and move this test light back to battery positive. I just want to double check that ground because it felt like maybe I wasn't just getting connection. So let me just double check that. I think we have two problems here. Hook that back up to battery positive. Check it works, which it does. We should have a path to ground there. We're not getting that path to ground either. So it looks like we have two problems here. So with this circuit here, I just want to double check both of them. We definitely are not getting power here, and we're definitely not getting ground here. So we have actually two problems going on here. So what I would likely do next is trace these two wires and try and find out where they're together, right? And they're probably together in a connector somewhere where there's a break and both wires are broken at the same time. And so that's where I would go to next. I'm not going to do that because now we're getting into sort of chasing some wires a little bit. I could also go and check ground 102 and make sure that it's okay, and I could check and make sure that power is leaving the ECM at this pin. But if I have two problems, and this problem just failed at one time, it needs to be, it's most likely not a separate problem here and here. It's likely something that affected both of them at the same time. So somewhere these wires in behind this fuse block are likely wired together somewhere where they've rubbed or broken and there's some sort of an issue. Okay? So that's where I would likely go next. But while I'm here underneath the fuse block, I'm going to take and verify that this side works. So pin 30 and pin 87, that's power all the time. If I touch those two together, current should be able to flow through here, close this, and turn the starter. So I can verify that side of the system while I'm here. So I'm just going to take and put two little jumper wires in here. So I'm going into those two pins, and I'm just going to simulate this closing switch here. So I'm just going to touch those two pins together. And we've started the vehicle. So the key was on. Which tells me that, you know, the key is activating the fuel pump and all those sorts of things. And then I took and closed this switch, bypassing the starter relay. So this whole system worked, the starter started, and we were able to crank the system. Okay, so I'm going to shut that off so we don't have noise and go off. So we're almost done diagnosing this system. That simple little test there told me all of this works. Okay? The relay's not clicking, so that told us that it's likely here. We're not getting power here, and we're not getting ground here. So the chances of two separate things failing, this ground bolt rusting out and this PCM failing at the same time, are very slim. So the next logical thing to do would be to take and chase this wire and find out maybe where there's a connection, where they're close together that maybe came undone, or someplace where they route where they could potentially break. And that gets a little bit more labor intensive than chasing some wire, but now we've at least narrowed it down to, you know, a fairly small area rather than just searching for needles in a haystack. So that's sort of a basic process of how we go through an electrical system diagnosis.